Good evening, students. All right, welcome to one more session of your WOC. This is your Vani ma'am, right? Back again with one more and the most important session that's nothing but the final revision. Yes, and that too, students, we are going to do this final revision one shot for all the term one chapters. Okay, whatever chapters are there, term one chapters, I'll be dealing with organic chemistry. All right. I'll be dealing with inorganic chemistry. Yes. I'll be dealing with physical chemistry. Yes. I'll be dealing with all the chapters along with your numericals also. Yes. How do I do that? I'm going to teach you the concepts, whatever are there, and whatever MCQs are there related to the concept, immediately I'll be solving it. Right, students? And this MCQ, whatever is there, everything is made from every line of NCRT. Line by line of NCRT is what we have picked up. So I feel that this is the most important revision which is required before your board exams. All right, students? All right. So, grade 12 students, all the best. Nothing to worry. Always remember, keep smiling. Right? So, keep smiling. You will always be the best. Right, students? All right. Let us start off with the session. Before that, let me tell you something. Always remember, WOC, your world of chemistry, is always with you all. Nothing to worry. I'm always there for you all. Yes, students? Right. All the best. Do your exam well. Vani ma'am is always there supporting you all. Let's start off the session. Before that, let me once check whether everything is getting recorded or not. Yes, so that there's no problem. Yes, it is getting recorded. Thank you so much. Let's start off with the session. First important thing, let us learn the concept. Yes. What are haloalkanes rather? Yes, students, the keywords. Just see, haloalkanes are what? First important thing, they are halogen derivatives, okay? Of which one? Of aliphatic hydrocarbons. Means what? If I take a alkane like this is your alkane, right, students? Alkane, hydrocarbon, the basic hydrocarbon. Now, what am I doing? I'm going to remove your hydrogen and add one halogen. Yes, so hydrogen is removed from here and halogen is added to this. So what does it become? It's going to convert into nothing but a haloalkane, right? This is called as haloalkane, or it is also called as alkyl halide. Yes, that is what is your haloalkane. Yes, derivatives of your hydrocarbons. Simple. Here I have taken one example, just like your chloromethane. Yes, students. And in this particular thing, when I take your alkyl halide, remember that all are single bonds. All are single bonds. Single bond, single bond, single bond, single bond. That's the reason the type of hybridization is sp3 hybridization. We very well know all single bonds means sp3 hybridization. If it is double bond means it is sp2 hybridization. If it is triple bond means it is nothing but sp hybridization. Right, students? Simple as that. So these are haloalkanes. Now, careful. Let us see one question corresponding to this. Yes, I said concept in MCQ. So dash are obtained by replacing one or more hydrogen atom of an alkane with the corresponding number of halogen atoms. Oh wow, that's a very important thing. Just check, students. What did they say? They have given me what is the thing or dash are obtained. What are obtained by replacing more hydrogen atoms of an alkane? Easy. It's nothing but haloalkanes. Yes. So once again, alkanes, when you take, remove one hydrogen, add one halogen, you will be getting alkyl halides or you will be getting haloalkanes. That's all. Simple as that. Let's go with the next one. Next, the general formula of monohalogen derivatives of alkanes. Okay, what is the general formula? Let us take. I very well know alkanes. General formula is CnH2n plus 2. Correct. Now, what did I do? I have taken out one hydrogen, I added one halogen. So, what did I do here in this case? Careful. These are hydrogens, isn't it? You will take out one hydrogen from here. Yes, right. You will add one halogen. So, Hydrogen here, basically, you're going to take out one and add one halogen. So what will it get converted to? CnH, 2n plus 1 and your X is there. See here, students. One hydrogen is replaced, one halogen is added. Is it easy? So remember that. So I'm going to underline halogen is here, hydrogen is removed here. Okay, done. Very good. So what is the option in this? This is the general formula. Next question, classification. So in classification, basically, haloalkanes are classified into different forms. See here, they're classified into monohaloalkanes, polyhaloalkanes. So what are monohaloalkanes? Wait, this is a general formula and you have only one halogen atom present in that. Yes, mono means there's only one halogen atom. That can be fluorine, chlorine, bromine or iron. Polyhalogen or polyhaloalkanes are those where you have more than one hydrogen atom of alkanes are substituted. Rather means there are more number halogen atoms, X atoms in this halogen atoms. Shall we see the classification? Let's see the examples. These polyhalogens are further classified into, see here, into di, tri and tetra. Di means what, students? You have two halogen atoms in that. Tri means what? Three halogen atoms in that. Tetra means what? Four halogen atoms. Rather, carbon is tetravalent, four halogen atoms. Again, dihalogen derivatives are divided into geminal and vicinal. So simple. Geminal means both the halogen atoms are present on the same carbon. What is it? They are present on the same carbon atom. Now check. When it is present in the same carbon atom, we call this as ethylidiene. Okay, what is it called? Ethylidiene or ethylidene or ethylidene. Vicinal are those where the halogen atom is present on separate carbon atoms. Okay, then I call this as ethylene. What to remember, students? For geminal halide, we call it as ethylidene. Ethylidene. For vicinal, we are going to call them as ethylene. So remember this. Easy? Right. Let us see any question is related to this. Further, there is further classification of monohalogen. See here. Dihalogen is derived into geminal and vicinal. Like that, monohalogens are divided into based on hybridization. What did students? I said something. Nah? What did I say? Basically, halogens are classified into mono and poly. Correct? Poly are again classified into di, tri, tetra. Correct? Di are again classified into, we have done just now, geminal and vicinal. Gem and vis. Correct? So let us see the classification of mono. Now see, sp3 hybridization. So the carbon, whatever is attached to halogen, if it has all single bonds, then I call this as sp3 hybridized carbon. If the carbon attached to the halogen atom, if it has double bonds, then I call it as sp2 hybridized carbon atom. Is it okay? Now check. Under sp3, first example is alkyl, second example is allyl. Third example is benzyl. Okay. What is alkyl halide? Observe. Halogen atom is attached to two carbon atoms, rather two or three more than that. So halogen atom is attached to an R group. Then it is called alkyl halide. Done. If I have to talk about allyl, check students. Halogen atom is attached to a carbon and that carbon is attached to a C double bond C. That means in allyl, the halogen atom is not directly attached. Okay, let me erase that so that it is not clumsy for you. Let me erase this. You will understand that better. Okay. Now in benzylic halide, what happens? Your halogen atom is again not directly attached to benzene, but you have an alkyl group here. Easy. So these three are sp3 hybridized carbon atom. Okay. Now sp2. Yes. The first example is vinylic, where halogen is directly attached to C double bond C. In arylic, halogen is directly attached to your C double bond C. Rather, in this case, it is like this, no students, it is like this. Right? So, this is where it is arylic. So vinylic and arylic are sp2 hybridized carbons, or rather easy. Now, monohalogen atoms are further classified over we have studied. Let us see. Let us see one question and understand this. Which of the following is an allylic halide? Okay. What did we learn? Allylic. So allylic halides are those. Let us see in which your carbon is sp3 hybridized carbon, CX bond. Okay. Let's draw this. Benzyl chloride. First one I'm drawing, it is like this. It is benzyl chloride. Okay, done. Next, 1-bromoethyl benzene. Okay, I have got a ring. Now 1-bromoethyl benzene. Okay, done. This is B. Then comes C, bromobenzene, where you have your bromine directly attached. In D, 3-chlorocyclohexene. Okay, 3 itself, cyclohexene, double bond first position. In the third position, I have bromine, also rather chlorine. So this is. Now see students, where do you have sp3 hybridization? Where do you have single bonds? Yes, the single bonds means here important thing, what is it? Basically your allylic means your CX or the carbon attached. So the halogen atom should be attached to Fp3 hybridized carbon. Okay. If I have to check in the earlier classification, allylic, see here, they should be a CH2 group and then a double bond. Correct. Now let us see which example. Okay, see here. There is a CH2 C double bond C group. Yes, and in this C double bond C, it is attached to one more CH2CH group here, and then you have your chlorine atom. Right, students, easy? Yes. So, important thing, double bond, after that you have a carbon. So, the option D is right. Easy? Okay, next question. Which of the following is not allylic? It is not allylic, they said. Oh, wow. Right. Careful students. See here. 3-chlorocyclohexone. So the compound is like this. Let us draw the compound and see it is like this. Next. 1-chlorobutene. So there's no place. 1-chlorobute 1-chlorobutene. This is the compound. Yes. So this is double bond is attached. Chlorine is attached to a double bond. This is which compound, students? Here directly attached. That's why it is vinylic. Vinylic. Okay. So this here, this particular thing, double bond. Let's see. Now what is chlorobutene? Okay. 1, 2, 3, 4. In this, chlorine is attached to a CH2. Okay, here also chlorine is attached to a CH2. Let us see the last one. Cl 3 chloro 1 2 3 double bonds. See here, chlorine is again attached to. So in between, if the chlorine is attached to a group and then it is attached to a double bond, then it is allylic. So in allylic, it should be double CH2 and X. Got it, students? Yes. So now in they said which is not. So here see. Here CH chlorine is directly attached to double bond. So directly attached, so it is vinylic in nature. Got it? Easy? Right. That's easy. So this is allylic. This is allylic. This is allylic. Okay, done. Now let us see. So the option, what is the option, students? B is the option. Okay, chalo, done. Which is not allylic. Next one, classification of monohalogen based on the nature of CX bond. Okay. Now see, basically the first type of classification is here, primary, secondary, tertiary. So in primary, what happened? They are the bromine or the halogen is attached to a carbon having two hydrogen atoms, and rather if I have to tell you, one alkyl or one X group. Okay. So on this two hydrogen atoms, and how many R group, students? One R group. Secondary are those which Carbon is attached to two R groups, one hydrogen and one halogen. Tertiary is where carbon is attached to three R groups, no hydrogen and one halogen. Yes, so these are nothing but tertiary. Let's see the question related. If two halogen atoms are attached to the same carbon atom of alkane, what is it called? Ah, yeah, I said two halogen to the same carbon. It is called alkadiene. Yes, I said, no, students, alkaline is or ethylene is gem. Alkadiene is nothing but your vicinal halide. No, sorry, alkadiene is nothing but, if I have to tell, it is attached to the same carbon. This is alkadiene. Yes, this is geminal. Geminal. So alkadiene is this. Alkaline is to a different carbon. Basically, it is this one is this one, two, bromine and bromine. Okay, students, this is what is it. Okay, so it is attached to the same carbon atom means it is nothing but geminal dihalide. What it is. So let us understand one more. Geminal dibromide. Which one is this? If I have to see this compound, see the same carbon you have two bromine atoms, so it is geminal. Easy. Okay. Next, the position of Br in the compound, yes, can be classified. Bromine is here. What is the position classified as? See here. Bromine is attached to a carbon, then attached to a double bond. So what is it compound, students? It is allyl in nature. Right? In allyl, what is hybridization? sp3. Done. All right. Next important thing, arrange the following example of a tertiary alkyl halide. Okay. Tertiary means what? Carbon is attached to three R groups, no hydrogen, and one X group. Correct? One halogen. Now observe. Yes, this is the carbon with one R group, two R groups, no hydrogen, and one halogen. So the reason this is your tertiary. Easy? Okay. Let us see the nomenclature of haloalkanes. Done. In the nomenclature, as we know, yes, this is the common name, this is the IUPAC name. So always what is the concept? In IUPAC name, we are going to give the preference to your alkyl halide rather. So the halogen, whatever is there, your numbering has to start from there. So if you're in this case, see here, it is one bro in this case, or one chloro, in this case one bromo, minimum number, in this case two bromo, like that. Even here one chloro, in this case two bromo. So your halogens are given minimum numbers. Okay, halogens are given minimum numbers. Got it? Suppose if you have a methyl group and your bromine, what is given preference, students? Observe, it is present on the same carbon, so you're going to check for the parent chain, whichever is longer, and start numbering it 1, 2, 3, 4. Butane. Easy. Suppose in this case you have bromine here. So start from here 1. Yes. So this is your second position. There is a methyl group here. And 1 bromo, 2 methyl propane. Propane is this longest chain which you have. Easy. Let us see some examples, MCQs on this. Further, you also have different examples if I have to see. Okay, let's see here. Now, if you have a structure like this is called neo. What is it called? Neo. How many carbons are there? One, two, three, four, five. Total are five. Yes, that's why it is pentyl in common name. But you have to start naming from here. So one. In the second carbon, 2,2-dimethyl. What is the parent chain? It is prop. Easy. Like that. You have the structure. All the IUPAC nomenclature, IU common names are there. Let's see the examples with this. Like that, if you see haloarenes. Haloarenes are those where you are going to, see students, you are going to replace the hydrogen with your halogen. Yes, see here. So haloarenes are are derivatives of are derivatives of aromatic hydrocarbons, are derivatives of aromatic hydrocarbons. carbons. That's nothing but benzene. Sure. Let us see the nomenclature. See here. Nomenclature, preference, order of preference. Remember, the halogen atom is given the minimum number. Wherever you're seeing, the halogen is given the minimum number. Start from the halogen and then proceed like this. Start from the halogen, proceed like this. Start from the halogen, proceed like this. If you have chlorine and bromine, go with the alphabetical order. Go with the alphabetical order. Easy? Okay. Now, let us see some questions based on that. See here. What should be the correct IUPAC name of diethyl bromomethane? Okay. They've given the structure. Let's write that. This is diethyl. Diethyl. Okay. Bromomethane. This is bromomethane. Now check students. Easy. How should I number it? Yes. You have to start numbering from here. Okay, so ethyl groups are there, so the parent atom is nothing but 2 plus 2 4 5. So is it not 3 bromo, because 1 2 3, right? 2, this is 2 carbon, this is the third carbon, so it is nothing but 3 bromo pentane. 5 carbon atoms are there. Let us see the next question. The IUPAC name of isobutyl chloride. Okay, iso. Okay, isobutyl means 1, 2, 3, 4. Right. Now, important. There's that isobutyl chloride. Okay. So, if I take chlorine in the first position, okay, isobutyl, they have not mentioned it. Isobutyl. Okay, important thing. This is your iso group now. This is your iso group. See here. This is your iso group which is there. Yeah. Right. So isobutyl I have written. Now let's see. Isobutyl. Okay. But perfect. Methyl perfect. So what is it? 1 chloro, 2 methyl propane. So if I have to check. Okay. If I have to check the compound, 1 chloro, 2 methyl. Now you said butyl. So what happened? How did I get 2 methyl propane? Okay, tech students, whenever you're taking a substituent of this, observe carefully. One, two, three, four. Yes, the but group, whatever is there, includes your isopropyl, and this should be your chlorine. This is right, this is wrong. So, because iso means you should have a T shape. Clear? That's the reason it is 1 chloro, 2 methyl propane. Right. You see? Okay. Let us see the MCQs on physical properties. Okay. So which is the correct order of the following? Okay. Increasing order. Now remember, students, the correct option is this. What is the reason? Yes. Careful. When you have the same alkyl group like this, remember, if the alkyl group is same alkyl group, okay, then what will happen, students? Same alkyl group, what should you check? Check for halogens. Halogens. So when you check for halogens, what will you get? Yes, yes, easy. RCl greater than RCl less than RBr less than Ri. Okay, done. Less than Ri. So which one has lower? Butane is less. Lower molecular mass than chlorine. Okay, let me erase this for you so that it is clear for you all. Okay, chlorine, then comes bromine, then comes iodide. Perfect? Yes. Next question. Sorry for this. So this is bromoethane. I'm sorry, students. So here the option is 1 bromopropane. I'm sorry. Then 1 bromobutane, and this is bromobenzene. Okay, because of the part which while taking it has got erased. I'm sorry. Okay, now let us see the option. Right. Here, what should you remember? This is the ethane molecule. One is prop, one is but, one benz. Which is changing? R group is changing. Remember, boiling point increases as molecular mass increases. Correct? Now, observe carefully. Observe carefully. In this case, subsay, which one is smaller? Ethane is smaller. Correct? Then one carbon, sorry, two carbons, three carbons, four carbons, here six carbons. So So boiling point increases as the molecular mass increases. That's all. Next question. MCQs and nature of CX bond. Okay. So which of the following is the correct statement of alkyl halide? Yes. When I see alkyl halide, because halogen is more electronegative, it will pull the electron density partial negative. This is partial positive charge. Yes. So because of this difference in electronegativity, it has polar nature. Polar nature. This is the most important thing. Alkyl halides are polar in nature. Yes. Next question. Most reactive alkyl halide among everything? Yes, B. Why? Larger the size of halogen atom? Yes. Yeah. Right. Lesser the electronegativity of halogen atom? Right. Next. Bond length. Larger is the bond length. Larger is the bond length. Yes, larger is the bond length of Ri. Yes, that's the reason. What will happen? It is most reactive. It is most reactive. It can easily break the bond easily and become active. Yeah, right. It can easily break and most reactive. Most reactive. Easy. Next question. General order of alkyl halides. General order of reactivity of alkyl halide. Yes. Right? Option A. Why? In case of tertiary carbocation is most stable. Most stable. What will happen to the product formation? Product formation also is stable. Product is most stable form. That's the reason. This is what it is. Faster reactivity. Most stable. It will easily break. Sorry, it will easily break and it forms the product faster. Okay. Next question. Which of the haloalkanes is most reactive? Just now I said, just now I said, for if the halogen atom, for given halogen atom, next, for given R group, remember students, the order for the given halogen atom is same in all. Then tertiary greater than secondary greater than primary. If the R group is same, then depend upon your halogen, iodide greater than bromine greater than chlorine. Now, see here which one? Which one, students? See here. Here all the halogen atoms are same. What should I check for? I have to check for halogen. So which comes first? Which comes first? Bromine, iodine comes. Is there iodine there? Not there. Then comes bromine. So this one. So one, two bromo because branching is there in that. Yes. All right. So easily I can break the bond with less boiling point. Yes, clear. That's the reason. So two bromo propane. Next one, reactions. Okay, see here. Here, these are all the summary of your reactions, summary of your chemical reactions, preparations and reactions. So here what happens with sunlight, it can and form haloalkanes. With bromine, it can form haloalkanes. With iodic acid, it can form. So with double bond, you can use Markovnikov's rule. With ethanol, using Lucas test, you can do form alkyl halide. You can use PCl5, PCl3, PCl5, red phosphorus associated to form your haloalkanes. Then haloarenes also, or haloalkanes, you can use different Schwarz reaction, Finn-Kilstein's reaction and form it. In the same way, I have taken different chemical properties, right? We are going to solve the MCQs for that. With KCN, because this is an ambidentate nucleophile and this is ionic in nature and this is covalent in nature. So you'll be getting cyanides and isocyanides. Yes. In ammonolysis, one hydrogen will get replaced. Yeah. Like that in if you take alcoholic KOH, elimination reaction dominates. Yes, if you take sodium in the presence of dry ether, Wood's reaction will happen. Yes, if you take dry silver oxide, you'll be getting ethers. Yes, if you take sodium ethoxide, you'll be getting ethers, right? Like if you take KNO2 and AgNO2, ambidentate ligands here again, this is also ambidentate ligand. Okay, they will be getting NO2 for KNO2 and nitrite molecule and nitroethane for AGN. Correct? So if this is what is the reactions based on this. Let's see the questions. In the following reaction, PCl3 on heating gives which products? Easy. PCl3 with ROH is going to give me a compound called RCl plus H3PO3. That's nothing but phosphorus acid. Is next one, ethyl alcohol and treating with thionyl chloride gives which gas? Easy. Ethanol on your thionyl chloride reaction in the presence of pyridine, it's going to give you C2H5Cl plus SO2 plus HCl. Is it right? That's all. You see? Next, identify the name of the following reaction. Okay, dry acetone, where you are converting bromoiodides or you're preparing iodoalkanes. What is it? Iodoalkanes is used, or we prepare iodoalkanes using Finckelstein reaction. Correct. Next question. The reactivity of following alkyl bromides towards iodide in dry acetone decreases in the order. Okay, it decreases in the order. Remember, students, first of all, which is this particular reaction? Yes, nothing. It's Finckelstein reaction. Okay. So preparation, just now we have seen, no? In Finckelstein, iodoalkanes are getting prepared from bromo. Right. Now remember, Finckelstein reaction always proceeds SN2 mechanism. Okay, SN2 mechanism. Right. So in SN2 mechanism, we very well know the order of SN2 is what, students? Yes, it is always methyl less bulky groups greater than primary, greater than secondary, greater than tertiary. That's all. What is the order then? Yes, this is methyl. Then this is secondary. This is primary. This is secondary. This is tertiary. So the correct order is this. Next question. Ethyl chloride on heating with alcoholic silver cyanide forms the compound X, the functional isomer of, yes. What is that? Ethyl chloride combines with AgCN, alcoholic, yes, it's going to form a compound called AgNC plus AgCN. Okay, now what did they ask us? The functional isomer of X. Okay, this is X. So what is a functional isomer, students? What is a functional isomer? Yes, the functional isomer of this is nothing but C2H5Cl. This is NC, this is CN. Correct answer is B. Is it? Okay. Next question. The order of reactivity of following alcohols of halogen acids. Let's see. So whenever somebody asks you order of reactivity, remember, order of reactivity of halogen acids is check tertiary greater than secondary greater than primary. Remember that. Okay, because the ease of which you can do the substitution reaction. Okay, so when HX comes here and adds, first water molecule is done and you get your tertiary alkyl halide. It goes here and correct. So the order is, so order for reaction of alcohols plus HX. The order is 3 degree more than 2 degree then 1 degree. What is the answer? B is the option. Clear? Next question. Which reagent will you use for the following? Which type of reaction, students? This one, you are getting one hydrogen substituted. Is it not free radical halogen reaction? Free radical halogenation reaction. Free radical halogenation reaction. So free radical always forms in the presence of ultraviolet light. Ultraviolet light, yes, or H nu, yes. So that's the reason the option is. Next question. Which of the following reactions can be used for the preparation of alkyl halides? Okay. Yes. Careful, students. This is nothing but anhydrous ZnCl2 plus HCl is nothing but Lucas test or Lucas reagent. Lucas reagent. The Lucas reagent is used to differentiate between primary alcohols, secondary and tertiary alcohols. Which will respond first? Tertiary will respond faster, secondary, then primary. So, which one can be used for preparation of alkyl ions here? Tertiary will give immediately turbidity, immediate turbidity. It doesn't require any reagent also. Means, nothing to heat, nothing. Anhydrous ZnCl is not required only for that. So, the correct option is this. Correct? With primary, if I have to tell you, the reaction is not possible only, it is very delayed reaction, very delayed reaction. Does not form, takes time to form. Okay. Okay. Next question. The order of reactivity of the following alcohols with halogen acids. Just now I said, my students, what is the order? If with halogen acids, alcohol plus HX, the order is 3 degree greater than 2 greater than 1 degree. Okay. What is the order in this? Easy. Same question almost repeated. Okay, sorry for that. Next one. Which of the following is an halogen exchange reaction? Okay, halogen exchange. See here, students. NX and RI. Exchange reaction. Where is it happening? Halogen exchange? Yes, in this case. First one. Next question. An organic compound A, okay, C4H9Cl on reaction with sodium diethyl gives hydrocarbon. Okay, what is what is A in this case? Okay, let us take. They said C4H9Cl. 1, 2, this is your 3. Okay, right. In the presence of sodium ether. Okay, this is Woods reaction rather. NaCl is out, and what do I get? I'll be getting a compound. Join both of them. Join both of them. Okay, plus 2 NaCl. Okay, done. Now you're going to take this compound. What did you say? To monochlorination. So you're going to do H nu in the presence of H nu and ultraviolet light. So you're going to chlorinate this compound. You'll be getting this compound, any hydrogen rather. You can chlorinate and see. So what will you get? This is nothing but, this is your compound rather, and this is called 1 chloro 2 2 T3 trimethyl butene. Yes, what is the compound, students? It is nothing but tertiary compound. So it is tertiary butyl. Right. Remember, Wood's reaction always happens with similar haloalkanes. Correct? That's the reason. Easy. Next question. Ethyl bromide can be converted into ethyl alcohol by. Okay. Ethyl bromide can be converted to ethyl alcohol. Okay. Simple, students. Remember, I can use, as I've written, moist silver oxide, Ag2O. Okay. If you add that, you will prepare alcohols from alkyls. Done. So what is the option here? Action of moist silver oxide. Next question. In which case of butan nitrile is possible? Butan nitrile. Okay, I can write that. Butan means C3. Nitrile means CN, KBr. What can I take? What should I take? Same thing. C3H7Br. Correct? What will I add? KCN. You're heating it. So KBr is out and butan nitrile is prepared. Butan nitrile. Correct? All right. Easy? Sure. Next question. So what is the option here? Next question. An alkyl isocyanide can be prepared from a respective halide by heating with. Okay. I have to prepare alkyl isocyanide. Okay. Remember, students, always Rx plus AgCN will give me RNC plus AgX. Rx plus KCN will give me RCN plus KX. Okay. So now what is it again? Alkyl isocyanide, they said. So easy. Okay. Next, ethyl halide on heating with AgCN. Easy. Ethyl halide with AgCN. Always AgCN gives me isocyanide product. And easy. Easy. B. So if you see AgCN, it is isocyanide. Next one. Ammonolysis of ethyl chloride in excess using alcoholic ammonia will yield which? Oh, very important. It's D. Why? See here. This reaction is called ammonolysis. What will happen? Your C2H5Cl plus NHHH. Right. Now what is going to do? You are going to heat it under pressure. So 1 ammonia goes and adds. Check students. First C2H5NH2. Okay, plus HCl. Again, you will add one more alkyl group like this. So the alkyl group goes on increasing, and your hydrogen keeps on decreasing. Same C2H5Cl. Same thing again. Your alkyl group goes on increasing, and your nitrogen or hydrogen gets less. Here NH, here hydrogen N. Further you heat it, that one also gets further reacted and you get a quaternary salt. You get a quaternary salt here. Quaternary salt, this is plus, this is minus. So this is called ammonolysis. You will be getting ethyl, triethyl, tetra, ammonium chloride, all. So all the compounds you're going to get. Next question. Identify X and Y of the following. Okay, let us see the students. So KNO2, when I talk, I said, what is it? It's going to form a compound. It is ionic compound. This is covalent compound. So what will it form? Methyl bromide always forms ionic NO2 ONO covalent compound. Done. Dehydrohalogenation process occurs. Okay. Dehydrohalogenation process means removal of hydrogen and halogen. Yes, yeah, right. The correct option is B. Why? In which hydrogen and halogen atom are removed from the same molecule. Yeah. If it is like this, I'm removing the hydrogen and halogen from the same molecule. If it is symmetrical and unsymmetrical, that is what you should check, students. Yes. If it is unsymmetrical on either side. If it is symmetrical on either side. If it is unsymmetrical on the same side. Next, reactivity order of halides for dehydrohalogenation is, yes, the option is B. Larger the size, or iodine is a better leaving group. Better leaving group. That's the reason. Okay. Next one. Alkyl bromide reacts with in ether to form 3,4,5 diethyl octane. Okay. Let us see this. 4,5 diethyl octane. Let's write the structure first. 1, 2, 3, 4. Okay, 4. Okay, 1 again. In the fourth and fifth position, I have ethyl. CH2, CH2, CH3. Okay, this is 4,5 diethyl octane. So from where will I get? Break this compound exactly half. You'll be getting, break the compound exactly half, and you will be getting CH2, CH3, Br. So I'm going to take 2 moles of this with Na, and in the presence of dry ether, I'll be getting this. Nothing but Woods reaction. Easy? Okay. Which of the following is the least towards Woods reaction? See here, students. The answer is A. Why? Why? Because in C2H5F, remember, the bond dissociation enthalpy is very high. Next important, fluorine is more electronegative. It will pull the bond. So it is least reactive. Least reactive. Right, students? Easy? Okay. Right. So in my next session, that is tomorrow, I'm going to send questions based on Markovnikov's and anti-Markovnikov's rule. We are going to see a lot. So wait for me in the next session. I'm going to do this questions, Markovnikov, anti-Markovnikov rules, questions, answers. In the next session, in tomorrow's video, wait for day 2 day 2 summary, right, and MCQs. Ready, students? Thank you so much. God bless you. Next video follows up immediately. Watch this, share it to your friends, share to all, right? Thank you so much. Bye bye.